Alright, so we're to talk about 8.1 sequences. Okay, what is a sequence? A sequence is really just a list of numbers. Okay, so a sequence is just a list of numbers. For example, we have 1, 1/2, 1/3, 1/4, okay, 1/n, and so on. N can be any number, 1, 2, 3, 4, and so on. Okay, and then it could be, for example, 2, 4, 6, 8, and then 2n. Okay. So normally a sequence is a set of numbers, and yes, normally there's a rule among it. Okay? There's a rule among it. So this is called sequence. And what we like to know about the sequence is that does the sequence converge to some numbers? So for a sequence, normally we denote it by, there are several ways you can denote it by. Normally we denote by an, and from 1 to infinity, like this. And this represents a1, a2, an. Okay. So for example would be, let me put a 3 here. So if I write down like 1 over n plus 1, and from 1 to infinity, that would mean what? When n is 1. So this means represents. Let me see if we can see 1/2. When n is 1, 1/2, 1/3, 1/4. Okay, 1/5, and so on. Okay, and what we're concerned about one thing, namely whether the limit exists and approach infinity, whether this exists. Okay. If this limit exists, and say limit an and approaching, say is L, okay, then we say that an is convergent to L. Okay. So if the limit doesn't exist, then we call it divergent. So if limit an and approaches infinity doesn't exist, then we say that we call it an is divergent. Okay. So convergent means limit exists. Divergent means limit doesn't exist. All right. So now let me give you some more. Okay, before we go on, let's look at those 2 examples. Okay, 1 and 2. And actually, 3 looks like 1 anyway, right? 3 and 1 is very similar, except the first term. All the rest is the same: 1/2, 1/3, 1/4, and so on. Okay, so for number 1, for the first sequence, for this sequence, 1, 2, the first sequence, 1, 1/2, 1/3, right? The first one. Limit, or this is nth term. limit of an equal to limit n go to infinity of 1 over, this is 0. Okay, 0 is a number, so therefore we say that this sequence n from 1 to infinity is convergent to 0. Okay, because the limit exists. The limit if limit an equal to L as n go to infinity, then we say that the sequence is convergent to L. So like this. So because the limit of 1 over n is 0 and go to infinity. So 1 over n is convergent to 0. And for the second one, the second one is what? 2, 4, right? 2, 4, 6, 8, 2n. This is the nth term. A sub is this one. Now if I take limit of the a sub n of this is limit n opportunity of 2n. This is infinity. Infinity is not a number. Important, infinity is not a number. So this is divergent. So this sequence n from 1 to infinity is divergent. Okay, because it approaches infinity. Infinity is not a number. Alright, now let's look at another example. Number 3. Okay, that's not not example we have here, but another example. Yeah, this is interesting. Okay, how about 1 minus 1, 1 minus 1, alternating. Minus 1 to the n plus 1 power. Okay, this is an. So when n is 1, it's negative 1 squared is 1. When n is 2, it's negative 1 cubed, it's negative 1, and so on. So the nth term is alternating 1 minus 1, 1 minus 1. Okay? Now, does this one converge? Well, the answer is no. This sequence, because this limit is jumping between 1 and the minus 1, 1 and minus 1. So this limit doesn't exist. It doesn't exist, so this sequence is divergent. Okay? Divergent.
Why doesn't it exist?
Divergent because it's jumping around between 1 and the negative is 1, negative. 1, 1, negative, 1, negative. It doesn't converge. Converge means for all the n, when n goes very, very large, all these numbers must all goes to one number, but it's jumping around between 1 and negative. So it is divergent. Because the limit doesn't exist, it's divergent. All right. Let me see if we can do some homework right now. We can do some homework. Or we can talk about, let me see. 1. Let me take a look at the problems I assigned to you. Nine to 37. Okay, 9 to 37. So let's look at number 9. Okay, number 9. So exercise 8.1, number 9. Okay, you see. All right. What's number 1? 9. Okay, a sub n, it tells us a sub n is 1 over 10 to the n. So the question is, write the first 4 terms of the sequence. So the question is, write the first 4 terms of the sequence. Okay? N from 1 to infinity. Okay? So, okay, no problem. First 4 terms, right? So the first term is when n equal to 1. Okay, this is always the first term, 1. So the first term. Okay, and then 2, 1 over 10 squared, 1 over 10 cubed, 1 over 10 to the 4th. Okay, so that's the first 4 terms. This one is very easy. Okay. So all the problems look at this. How about number 15? Again, the same question, write the first 4 terms. An is 1 plus sine n pi over 2. Okay? So first 4 terms, the same question. Okay? Write the first 4 terms. So A1 is what? Is 1 plus sine 1, right? So pi over 2. Sine pi over 2 is 1. It's 2. A2 is the second term, 1 plus sine 2, right? 2 pi over 2. So 1 plus sine pi. But sine pi is 0, so it's 1. A sub 3 is 1 plus sine 3 pi over 2. Sine of 3 pi over 2 is negative 1, it's 0. And the fourth term is 1 plus sine 4 pi over 2. So this is 1 plus sine of 2 pi. Sine 2 pi is 0. So this is 1. 2, 1, 0. Okay? That's the first 4 terms. Number 15 is same question. Write the first 4 terms of the sequence. So, the first term is n equal to 1. The second term is n equal to 2. And then n equal to 3 and n equal to 4. Okay? Alright, so now sometimes the problem might not be so obvious. So they want us to, again, same questions, write the first 4 terms. But number 17 is a little bit different. Number 17 is this. The way it defines it is like this. A sub n plus 1 equals 2 times an. And then a sub 1 equal to 2. Okay? So, same question. Write the first 4 terms. Alright? So, the first term they will tell us is A1 is 2. Now, how about the second term, A2? What is A2? A2, right, is when n equal to 1. A2 is, if I use this, right, 2 is when n is 1. So A2 is 2 times A1. So it is, but A1 is 2, right? So it's 2 times 2 is 4. Okay? And then A3 will be when n equal to 2, right? 2 plus 1 is 3. So 2. So this is 2 times A2. 2 times A2 is 4. 2 times 4 is 8. Okay? And then one more. They want the first 4 terms. A4 is equal to 2 times A3. A4 is 2 times A3. A3 is 8. 16. Okay? This is easy, right? This one is the easiest follow the definition. So all the problem here looks like this. This group to 37, right? The problem, yeah. Okay, let me see if we can. Let me do one more. How about 21? Okay, this is page 3. Okay, let me do the next one. Page 4. How about number 21? Same question. Write down the first 4 terms. So A sub n plus 1